section has to do with cross products, and this will serve as a review. So remember that the cross product of two vectors A and B, so A cross B would equal to C, and this means cross product. It doesn't mean multiplication. So the magnitude of the vector C can be defined as the magnitude of the vector A multiplied by the magnitude of vector B times the sine of the angle between the two vectors. So it might look something like this, where this is A, B, and this is the angle between them. This vector C has a certain direction, and it's actually perpendicular, always perpendicular, to the plane that contains vectors A and B. So for example, let's say I have this as my x-axis, this as my y-axis. Z-axis is coming out of the paper. And let's say this is my A vector, and this would be my B vector in this example. So using the right-hand rule, I would have A, so you first start off with A, and you swing your hand in the direction of the other vector, and the direction that your thumb points in is the direction of your C vector. So that would mean A cross B is equal to C, and we know that C is directed in the positive Z direction. Let's consider B cross A. So now what I have to do is, again, use my right-hand rule, direct my fingers along the B vector, swing it into the direction of A, and my thumb will point into the paper, and that would actually give me a C vector directed in the negative Z direction. So they're very different. Here are some rules that we need to be aware of for cross products. So the order does make a difference. So the order does make a difference. A cross B does not equal B cross A. We can also multiply a coefficient to this cross product. So let's say we have a scalar value A, and we have it multiplied to A cross B. And I can expand that further by saying A times the vector A, cross it with the vector B. That would also be equal to vector A cross the coefficient cross A times the vector B. And finally, I can have the vector A, and I can cross that with the sum of two vectors, let's say B and D, and that would be equivalent to saying A cross B plus A cross D. So how do we actually calculate this cross product? So how to calculate the cross product of two vectors? In other words, what is A cross B equal to? So let's say A is given by AXI plus AYJ plus AZK. And B is given by BXI plus BYJ plus BZK. We can use determinants to compute the cross products. So we can use determinants, and it goes like this. So A cross B would be the determinant written in this fashion, where we have the I component, J component, and K component, and we have AX. You have to make sure that the second row is this first vector shown here. So it would be AXY, AZ. And this third row is for this second vector shown here. So BX, BY, BZ. So a simple way to memorize what the determinant is first you cover up I, and that would give you the I component, and that's AY times BZ minus BY times AZ. For the J component, you cover up the J column, and it would be a negative or a minus sign, always a minus sign. And that would be AX times BZ minus BX times AZ. And finally, you cover the K column, and it's a positive again, or you add it, and that would be AX times BY minus BX times AY. So this expression right here is the cross product of A cross B. So one last tidbit about cross products. Sometimes it's not necessary to use a determinant. Sometimes all you want to know is just what is I cross I, or I cross J, or I cross K. J cross I, J cross J, J cross K, K cross I, K cross J, and K cross K. So it turns out that when they're the same, I cross I, J cross J, and K cross K, they're equal to 0. However, for the others, they're not equal to 0. In fact, J cross I is a negative K, and the reverse of that, I cross J, is a positive K. K cross I is a positive J, but the reverse of it, I cross K, is a negative J. And K cross J is a negative I, and this is actually a positive I. So how do I know this? So a trick that I want to show you is called the cross product wheel, and we label this I, J, and K. So with I, J, and K written, I'm also going to make another few notation, and I'm going to say if you move in this direction, we'll consider it as a negative value, and if you move in this direction, we'll consider it as a positive value. So let's check this out. What what this means is I cross K should equal to a negative J. I cross K should equal to a negative J. So that checks out. K cross J should equal to a negative I. K cross J is equal to a negative I. J cross I should be a negative K. Let's go the other way around. Let's go I cross J should equal to a positive K. So I cross J is equal to a positive K. J cross K is equal to a positive I. So J cross K is equal to a positive I. That checks out. And K cross I should equal to a positive J. And that checks out. So all of it checks out. So you really don't have to memorize this. All you really need to do is memorize this wheel right here.